Good morning, sir.
Good morning. How are you?
Very good, thank you. Good morning, Rose.
Hola, hola chicos, ¿cómo están? Buen día. Hi, good morning. Okay. Okay, Lourdes.
Good morning, guys. Ariana, Marx, Minoska, Camila, good morning. Samuel. The class going to be the start right now, okay? Teacher says the class is yours. Guys, enjoy the class and learn, okay? If you had some questions, you can turn your microphone or you can chat, you can send your question by chat and the teacher going to answer, okay? Okay, teacher, you can start the class.
Okay. Okay, so today's topics are system of linear equation in 3 variables. The second one is determinants of order 3. Next one is the roots of polynomials. And the last one is remainder theorem. Okay, so let's start with the system of linear equations. So system of linear equation means we have linear equations like we have before in mx plus b is a linear equation. Let's say ax plus by, that's a linear equation. So now, but now that we are doing in particular is system of linear equation in 3 variables. We have 3 variables x, y, and z, and we will have a system. We have the system of linear equation. So let's say we can have like so it will be like, okay, just let me. So let's say if we have like 3 lines, 1, 2, 3. Just imagine these 3 lines for now. So these are, let's say these are the 3 equations of 3 lines, but an equation of a line is 2 variable equation. Equation of line is 2 variable, like y equals to mx plus b. That's an equation of line, but it's in 2 variables, this and this. When we go to the 3 variables, let's say ax plus by plus cz equals to d, let's say like this. This is now an equation in 3 variables, x, y, and z. Now, this one do not represent the line. This one represents the line here, but this one do not represents the line. This one, what does this one represents? This one represents a plane. In 3 variables, we get a plane sheet like that. This one represents a plane. So now we have a plane. We do not have a line, but we have a plane like this. So this, it can be represented by 3 variables. So when we are in 3 variables, we are talking about the planes. So now when we talk about the system of linear equation with the lines, let's say we had 2 lines, we want to see the system, we want to solve the system. We was looking at where these 2 lines intersect. Okay, if these 2 lines, wherever these 2 lines intersect, that's the solution of those ones. Let's say if 2 lines are parallel, they do not have any solution. And if 2 lines they are overlapping, 2 lines are overlapping, same thing, same like overlapping over the same place, then they had the infinite many solutions.
Danny, please, te prohíbo que entres a esa clase.
por tu seguridad, I don't want you to stay in that class, okay? Get out from the class. Get out from the class. Please. Don't be in the class.
Okay, so next is,
Don't worry, teacher. You can continue with the class, okay?
so now let's say we are having the planes, all right? Instead of lines, we are having the planes. So what we do is, like how they look like, let me show you. So, okay, so if you can see here in this one, so now what we have is, we have the planes. We do not have the lines, but we have the planes. So the possibilities that when two planes intersect or three planes intersect, let's say when this is like the scenario when two of them intersect, let's say we have a plane like this. So they're intersecting. When the two planes intersect, they give us a line like this. But now we have more than two. We have, let's say we have three planes that are intersecting here. So if they're intersecting at one point, you see this is the one common point in them. So this one point is unique point, and that's the solution for that. But in the second one, you can see here, this one is one solution. This one have one solution. The first one, it's unique, it's a point. Second one, you see it's a line. It's a line. So this one will have infinite many solutions, because this whole line is the solution. And now in these ones, this one have no solutions. These ones have no solutions. If the two planes intersect, but the third one don't, so they don't have any common point. Similarly, no common point where they intersect all of them. Similarly, like if they parallel like this. So these are the scenarios when they can have one solution, infinite solution, and no solution. So let's go back and let's see. Let us solve a system of linear equation using three variables and see how we can solve it. So let's say we have question x minus 2y plus 3z equals to 9, minus x plus 3y minus z equals to minus 6. This one is z, don't get confused with 2. And this is 2x minus 5y plus 5z equals to 70. All right, so here we have these three equations. And we want to find the solution for this system of linear equations in three variables. So solution means we want to see, is these three planes intersect at one point, or is this give us a line have infinite many solutions, or is this one do not intersect, or the two of them intersect at different places. So we want to see if it have solution, if it have no solution, and if it have the solution, then what solution is it. So first of all you do is you give them the names. You can give them the number or give them the names. So let's give them the name A, B, and C. So we follow the same rule like we solve the two variable equations. We will try to look at the elimination method. So if you look now, first of all we need to decide which variable we want to eliminate. Let's say I want to eliminate x. Okay, I want to eliminate x. Now what I need to do is I look at the equation 1 and equation A and B. So if I add A and B, what will happen? So I can add them. Sorry. So okay, so let's add them. So the x and the x will vanish, where they will cancel out. We will have y plus 2z equals to 3. So we get another equation. Let's give them the name D. So now we got y plus 2z is equals to D. All right. Now let's try. What we do is now we pick another pair of lines. So let's say we pick A and C. Okay. But to do that, we can see that the coefficients of A and the C, they are not same. The coefficient of A is 1 and this one is 2. So what we do, and they have the same signs. They have the same sign. This one is plus, this one is plus. So what we can do is we can multiply them, like the first one by the -2. We can multiply the first one by the -2 and then add. Okay, so we multiply equation A by -2 and add with C. So when I multiply the equation 1 by equation A by the 2, I will -2, I will get -2x plus 4y minus 6z equals to -18. All right, so I get that. Now I add it with the equation C. Let's add them. So x and x will cancel out. This will give us y minus z equals to -1. So now I have two equations. Let's give this the name E. Now I have two equations. D and E that are in two variables, y and z. Here we also have y and z. So we have two equations that are in two variables now. So what we do again now is, now you can see the coefficients of the y. Let's eliminate the y. The coefficients of y is 1 here and the y is 1 here. So what we do is we can, but they're same, so we can subtract. Okay, now subtract D and E. So now let's just subtract D and E. So let's say I write the D on the top. Y plus 2z equals to 3. And I subtract. Subtracting means put the negative outside. Okay. So y minus z, or wait a second. Let me just write it and then I will change the signs. So you can just write it and then you can change the sign because you are subtracting them. So since we are subtracting, so we will multiply everything with -1, so it will change the signs. Now these are the signs for the grid, for this one, the red color one, because we multiplied it with negative to subtract. Okay, so now let's resubtract then. So this will become 0 and this will become 3z equals to oh, sorry, I think we made a mistake here. Okay, this one, sorry, I made a mistake in calculation here. Let me correct it. This one was negative because it was 4y minus 5y, so this one was -5y. Sorry. So this one was -5y, -z, and -1. All right, so now they have the different sign already. So now they already have the different sign, so we can add them. Add E and D. Now let's add them. So we get y plus 2z equals to 3 and -y -z equals to -1. So this one is D and this one is E. Now we are adding them. So we are adding, so we do not need to change the signs. So this will be 0 and this will become z equals to 2. So z is equals to 2. So what we got here is we solved our one of the equation, which is z is equals to 2. Now if you see, if you remember, we have e, the equation e was minus y minus z equals to minus 1, and we already know, we have already found that z is equals to 2. So we can find the y from here by substituting in e value of z. All right, so we are substituting the z in e. So negative y negative 2. So we will get negative y negative 2 equals negative 1. We will add 2 on both sides, and negative y equals to 1. So y equals to negative 1. So now we got x, now we got y. Now we have the choice. We can use any of the given equations that we had. We can use any of the given equations that we had. Let's say I'm using a now. Okay. Now let's using the a. That was x minus 2y plus 3z. That was the equation a that we have. Okay. Now we will put the values of the x, the y and the z in it to find the x. So x minus the y value is minus 1, 2 times minus 1 plus 3 times the value of z, which is 2. So x plus 2 and then plus 6 equals to 9. So that's 8. So x plus 8 equals to 9. So x equals to 1. So now I have a point which I can write it like a point. It's point in 3 coordinates. X is 1, y is minus 1, and z is 2. So this is the point where these 3 planes intersect. This is the point where these 3 planes intersect. So it have one solution only. So it's a unique solution, and this system do have a solution. We got a solution, so this system do have a solution, and that solution is a unique solution. Okay. So now I'm moving to my next topic. That's the next topic that we have here. That is determinant of order 3. So like to find the determinant of order 3, you should know like what the, basically we can find it without, so we should know what the determinant of order 2. Let's say we have a matrix, A, which is 2 3 1 4. It's a 2 cross 2 order matrix. So let's see what does the determinant of this one means. Determinant of A is written like this. Okay, determinant of A, you can put the straight lines, or actually let me use the general alphabets A B C D. Okay, so let's say we have like this. So what we do, the rule for the determinant of 2 cross 2 matrix is we should multiply the A times C, A times D, this diagonal, and then minus in the middle times the second diagonal. The elements these are called the diagonal elements. Okay, so that's the way to find the determinant of 2 cross 2 matrix. So now what we want here is we want to find the determinant of a 3 cross 3, a 3 order matrix, order 3. So like it will be something, let's say we have matrix A here, A, B, C, D, E, F. Okay, like this. And we want to find its determinant. So now we are looking for the determinant of order 3. So first of all, we can write it like the determinant of A is with the symbol of determinant. And there is two methods. One is a shortcut, one is a bit longer. So like to find the determinant of the 3 cross 3 matrix. So what we do here, these elements like A, B, C, D, they are like, if we can, these are called the elements. These are the elements, and these are the entries. These elements are the entries of the. So the first entry, the first one is called, it's 3 cross 3. So this one is the rows. These ones are the rows, and these ones are the columns. So how we represent it by, so rows are represented by I, and the columns are represented by usually J. So what we do here is we can start with it, we can expand. Now we need to do is we need to expand the determinant for 3 by 3 by picking it like this, that you can start it, you can expand it from any row, from any column. Let's say what we need to do is, you need to do is like this. So you write it, the -1 to the power I plus j. Here I is the row and j is the number of column. I row, j is the column. And then the entry that we get, let's say we can expand it from any row or any column. Let's say we expand it from the first one. So let's say we got first A here, then you eliminate this row, the one that you picked, and that column. We picked the A to start with, we eliminate the first row and the first column, and you write the remaining. Again, then plus -1 to the power, or you can just write -1 to the power I plus j again. All right. Okay, so just writing this for example. Look, so if you see, what is the I plus j in the, what's the first row here in this one here? The first row is the first row, first column. First row, first column. Here, I plus j, it's the first row, second column, right? And then times it with the, okay, now we are at the first row, second column here. We eliminate these and we write the rest of it, D, G, F, and I. And then again, for the third one, -1, and it's the first row, third column. And then, oh sorry, and then the entry is this entry, that entry there's C, that entry is C here. And then you eliminate that row and that column, the entry that you have picked. We have picked C, we eliminate this and this row, this column, like this. And then we write the rest of it, D, E, G, H. And we have already seen that, like we just saw the rule how to solve a 2 cross 2. So then we just solve these 2 cross 2 and then multiply it with them. All right, so it will become like 1 plus 1 is 1. So it will be A times EI minus HF. So this will be 1 to the power 3. Whenever -1 have the odd powers, it gets negative. So minus, oh, I missed this B here, sorry, please. This B was missed here, okay, the entry. Then we have B times the expanding the determinant of 2 by 2, DI minus GF, and then again 1 to the power 4, -1 to the power 4, that will make it positive, and then C times DH minus G. So that's how we can expand the determinant of 3 by 3. That's how we can find the determinant of 3 by 3. Let's find the determinant of 3 by 3 by this method, and then we'll quickly look at another shortcut method for the determinant of 3 by 3 as well. So let's say we have 2 minus 5, 3, 0, 7, -2. -1, 4, and 1. We want to find its determinant. Okay. So let's call this a determinant. So what we should do is we should pick the first. Okay, we can pick it, we can expand it from any one, we can expand it from any row and any column, but just a normal practice is that we usually just expand it from the first row. So let's just start with from the first row. So the first row, this one will it's -1 to the power 1 plus 1 entry, first entry, times determinant. So if we skip the first row, first column, 7, 4, -2, 1. Then again plus -1 to the power 1 plus 2. First row, second column, 1 plus 2. This is row plus column. Okay. Number of row plus number of column. And then the entry is -5, and then we skip the first row and second column. First row and second column. And then you write the remaining. And then again the row, first row, third column, and the entry here on the first row, third column, that is 3. And then we skip the first row and the third column. So once we skip, okay, so we will get 0, -1, 7, 4. And we saw before that how we can expand these 2 by 2 matrices or determinants. So this will become positive. So 2 times 7 times 1 minus 2 times 4. Plus this will become minus. This will become -1 times -5 times 0 times 1 is 0, -1, and then minus from the formula, -1 times -2. Then we have this one is become +1, so 3 times 0 times 4 is 0, and then -1 times 7. That will get us to 7 minus 8. This will again become plus 5 times. So this will be minus times minus will be +2. +2 and minus is minus. And then plus 3 times. So this one will be -7. This one will be -7 here. And -7 times minus is +7. So that will be 7. So we have 2 into -1 plus 5 into -2 plus 3 times 7 -2 minus 10 plus 21. Okay, so that is 20 21 minus 2, that is 9. So the determinant for this one is 9. Okay, so there is another shortcut trick that we can use. That is, let me explain it to you with this same example. Okay, let's say we had 2, 0, -1, -5, 7, 4, 3, -2, 1. Let me see if it's the same. Okay, so what we do here is you pick the you multiply the diagonal elements. Let me first rewrite it. Okay, first what we do is first we rewrite it. First we will rewrite it. But we will rewrite it like this. And then 1, 2, 3. Okay, then we will repeat the first and the okay. Now let's like this. It's not determinant now. Like we were trying to find determinant, but we wrote it like this. So we repeated the first and the third column. So we repeated the first and the third column. Okay, so then the next thing is what we do is this one. Okay, let me share it. So what you do, you multiply this one, you multiply these ones, and these ones, and you put the plus sign with them, plus plus plus, and you add them. Like you multiply these three and then you add them. The next is then what you do is you multiply, you start with like multiply like this and this, but you subtract them. All right. Okay, so now I'm writing the adding one first. So 2 times 7 times 1, what will be that? 2 times 7 times 1, the first one, that when we multiply it, it will be 2 times 7 times 1, okay, plus minus 5 times minus 2, minus 1, okay, minus 1, like this. And then the third one, plus 3 times 0 times 4. So anything with 0 is 0, multiplied by 0 is 0. Okay, so this is the 1 plus 1's done. Now we have the minus 1's. So minus into minus 1 times 7 times 3, and then minus 4 times minus 2 times 2, and then again the third one is 0, so that like we get this 0 in the middle, so when we will multiply it, it will be 0. So now let's do it. It's 14 minus 10, okay, and then plus 21, minus 10, okay, plus 21, and then let's see. Okay, so the next one is 16 plus 16. Have we written it correct? Wait a second. Okay, so 14 minus 10, then 0 minus 20. Okay, so plus 21 and becomes plus 16. Okay, so let's add it. So 14 minus 10 plus 21 plus 16. Okay, I'm getting 41 for this one, but okay, maybe there is some, I don't know, I'm not sure, because we're having a different answer, so maybe we made some calculation mistake adding subtracting, but this is the rule. So what we do is we repeat the first and the second, we repeat the first and the second column again, and then we multiply like this, the diagonally, first diagonal, second diagonal, third diagonal, with the plus plus plus, add these three, then the lower diagonal, first lower diagonal, second lower diagonal, and third lower diagonal, and then we subtract these three. So that will give us the determinant. So that's a quick way to find the determinant for 3 by 3. Okay, so this is the next topic, that is third topic is roots of polynomials. Roots of polynomials. So roots of polynomials means the number that when we plug into them, they give us, the polynomials or functions are like this. Let's say the p of x is, let's say we have a polynomial function is, polynomial functions are like this. Let's say 5x, or maybe like, let's say I have x8 minus 4x7 minus 18x6 plus 108x5 minus 135x4. So let's say like that. So these are a polynomial function. This is a polynomial function. It have a degree. This one, the highest power represents the degree. The highest power represents the degree. Its degree is 8. So the number of roots is equals to degree. Okay, and the number of roots include both imaginary roots, imaginary or complex, imaginary or complex roots, plus the real roots. The sum of imaginary roots and the number of imaginary roots or complex roots plus the real roots, it's equals to the degree of the polynomial. Let's try to see. So let's say we have a polynomial like this. All right, so we want to find the roots of this one. So I assume that you may be familiar with the synthetic division. So we will use that synthetic division to find the roots for this one. So to find the roots for this one, what you just look at is you look at the last number and the first number, and you see which numbers can divide it. So let's see which numbers can divide the 40. Let's start with that. Okay, plus minus, obviously always start from plus minus 1. Plus minus 1 can divide, plus minus 2 can divide, plus minus 4 can divide it, plus minus 8 can divide it, plus minus 10 can divide, plus and minus 20 can divide it, and plus and minus 40. These are for this one, the last number C, the number without the X. Okay, so we look at that. Okay, so what you do is you start, like you can check it on your calculator. Let's say we start the synthetic division by picking the number from here and see which one gives us the remainder as 0. So let's say I start with plus 1. Okay, I'm starting with plus 1. So to do the synthetic division, you write the numbers only, the coefficients in order. First highest power, then the lower power than that, then the lower power than that, then next lower, and then like this. Okay, so let's say I'm starting with 1. Okay, I'm starting with 1, like x equals to 1. I'm saying that's the root x is equals to 1. The root is 1. Just check. So you do is you first of all you write it like this, it comes as it is, then you multiply. 5 times 1 is 5. So minus 2 plus 5 is 3. Then you do 3 times 1, this number, multiply this number with that. That gives us 3, so get 8. 8 times 1, that gives us 8 again, so 58. So 58 times 1 is 58. So 58 minus 20 is 38, and then we subtract the 38 from it. It's the 2. Remainder is 2. It's not 0. So x equals to 1 is not root. Okay, now let's try. I'm just redoing it here. Let's try with -1. Okay, let's try with -1. You can use you don't have to like do this like this. You can use calculator to do it quickly. So let's try with the -1 right now. Okay, again. So now I'm saying x is equals to -1. I'm checking the number, second number -1. So 5 comes down as it is. Then 5 comes down as it is. Then I have 5 times it's -5. 5 times -1 is -5. That will give us -7. Then -7 times that will give us again 7. So it becomes 12. 12 times it will give me minus. Okay, so okay, sorry, there's again a mistake, a small mistake. This was 20. I wrote 2. Sorry. Okay, so let's recorrect it again with the same root. This was 20 here. This number was 20, so it should be 20 here. Okay, so let's try again. So 5, then -5, it will give us -25. Minus 25 times -1 is +25. That will become 30. So 30 times -1 is -30. That will give us 20. 20 times -1 is -20, and then that will give us here -40. -40 times -1 is +40. Okay, so we got a root. So x equals to -1 is root. Now you look at here again. You look at this thing again here. You can rewrite it back. So now our next polynomial, the polynomial that let's say I call it q of x, the intermediate polynomial that we have got is you write them like this. Let's say okay, so then you got 20x first without any x power, then 1x power, then x squared, and then x cubed, and then x power 4. So this is again the polynomial that we got. So we can again look at it. We can see which one of these like number divides, and then we can again do that. So let's okay, so let's try it again here. So we got this. Now we can check again here. This is already written here. So now let's check again. So we have this, the last number is -40. So -1 can still divide it. All right, so let's check it if the -1 still works or not for this one, for this next polynomial, intermediate polynomial that we have got. So it's 5. It comes down as it is, -1, -5 here. It will give us -30. This will become +30. 5, okay, and -30. Oops, sorry. Okay, so this one now we have +30 here again. It will become 60. Now 60 times -1 is -60. This will become -40. -40 times -1 is +40. Okay, so -1 worked again. -1 worked again for this one. So now we have two roots. X equals to it's the repeated roots. These are the repeated roots. X equals to -1 and -1. Now let's check, is -1 works again here? If not, then we will check the next one, like we will check the 2 or something like another number. So it will give us 5, then again -35. This will become +35, right? So that's like 95, and we know that when we subtract the 95, it's not going to be 0. So -1 don't work anymore for this one. Let's check 2. Is 2 is a root? So like let's check the 2. So let's check if 2 works. So 5 times 1 is 5. It comes here down as this. 5 times 2 is 10. This will become -20. -20 times -2 is -40. Okay, it will give us 20. 20 times 2 is 40. Okay, so this gives us 0. So now the 2 is also a root. So 2 is also a root because 2 gives us the 0 when we do the synthetic division. So last thing that we have here right now is we have 5 minus 20 and 20. We have 5 minus 20 and 20 from above that we have got. Let's check what numbers can divide 20. 2 can still divide 20. We have already checked the 1 minus 1, that didn't work. So now we are checking 2. 2 worked once, but we can check it again if it still works or not, because it still divides the 20. And then so let's do the synthetic division again. So this will become 5, should become 10 here. 5 times 2 is 10. So this will give us negative 10. Negative 10 times 2 is negative 20. And that gives us 0. Okay, so this one worked as well. So now we can rewrite this, the last one. We can rewrite the last one as 5x minus 10. And 5x minus 10 here. So we know that, okay, so to solve that one, we want to find when 5x minus 10 is equals to 0. We can simplify it, like 5x equals to 10. So x equals to 2. So we got 5 roots in total. We got 5 roots in total because this was 5-degree polynomial. Minus 1, 2, 2, and 2. So if we want to write it like as a polynomial, these are the roots. These are the 5 roots of that polynomial. So if we want to rewrite it, we can write it as x minus 1, x equals to 1. Sorry, x equals to 1 is a root. X equals to minus 1 is a root. So x minus 1 equals to 0. So applying the factor theorem on all of them, we can write it like this: x minus 1, x minus 1, x plus 2, because so x minus 2 is like x plus 2 and then x plus 2. So this is like we have factorized this polynomial as well. This was not the part necessary, but you can rewrite it back like this in a factorization form as well. So these are, from here we can form the roots. Okay, now the last thing is the remainder theorem. Okay, so the remainder theorem tells us, if polynomial p of x is divided by binomial means that have 2 terms in it, by the binomial x minus a, then remainder is obtained is p of a. Like instead of dividing it, if you want to find the remainder, if you plug in the a in that polynomial, you will find the answer. So let's say, for example, let's say that it's like this. So p of x divided by x minus a, you will get some quotient, something in the quotient, plus a remainder, something in the quotient and a remainder. When we divide a polynomial by x minus a binomial, we get a quotient and a remainder. And if we want to find the remainder, let's say we have the polynomial p of x 3x cubed plus 2x squared minus 6x plus 1, and let's say we divide it by the binomial which is x minus 2. Okay, let's say I'm dividing it with another binomial x minus 2, right? That's so like we can divide it with the long division and then can find the quotient and the remainder, but the remainder theorem tells us like we have x minus, so that x minus 2, so it means like it says x minus a when we saw there, so it means the a, if we put the p of a, we need to find p of a. So what's the a is equals to in this scenario? A is 2, right? So if we find the p of 2, that will be So that was 3 into 8 plus 2 into 4 minus 12 plus 1. So that's 24 plus 8 minus 12 plus 1. Okay, so that will give us 21, I think. Yeah, I think it gives us 21. So 21 is the remainder. Like this. If we divide this thing, let's say even if you do it with the long division, let's say you write it like this, and you divide it with x minus 2 here. The final, like whatever you're doing after doing the whole thing, the remainder that you will get here would be 21. But with the help of remainder theorem, you can just plug in the 2 here and you can get the answer without doing this whole long division. But to find, if you want to find the quotient, then you need to do the long division. But the remainder theorem tells us that you can find the remainder directly if you plug in this a here in the polynomial. Okay, anyone have questions?
No, teacher.
Everything is clear, guys?
Yes, teacher.
Okay, very good, excellent. Okay, so excellent class. Thank you
Thank
guys
you.
for being here. Dependent for next class. And have a wonderful day to all of you. Wonderful day to you, Sad. Enjoy this day.
Thank you.
I'll see you next class, okay? Bye-bye.
Bye, teacher.
Bye, Samuel, Camila, Mark.